Okay, what I'm going to do here is do a speed, time, and distance, a 3-point fix, a distance off, and a relative bearing. Those are the things that you really do need to know. And I'm going to work pretty much out of our book here as well. So I'm going to take one of the examples on page 45, and we are going to go from H to K. So H being down here, and we're going to go to K, which is way up here. So first thing I do is I draw my DR line. And again, the center up to the base of the other buoy. The first thing I'm going to do is I'm going to then take my ruler, rolling ruler, and mark it off to the center of the compass rose. And again, you have to go through the center of the compass rose. And because we're going from H to K, put a little arrow up there, I'm going to read that side of the compass rose, and it's going to be on the outside, which is true. And what I have there is 007 true. Now, I want to find out what the distance is, so I'm going to mark off 5 nautical miles. And then I'm going to go from there up, and then I'm going to swing the rulers and then squeeze down to the base. Let me make a little adjustment there. There we go. And then I come back, now I got 5. So I got 6.8 nautical miles. So 6.8 nautical miles. Now, if I want to do an ETA, and I'm telling you that we're traveling at 8 miles an hour, so I draw 60D straight. Please draw those all the time. 60 times our distance, which is 6.8. And if we're going to go at 8 knots, our speed, and if we do the math here, you got 6.8. So I got 6.8 times 60. I'm going to divide by 8, and my ETA will be in 51 minutes. Pretty straightforward. So again, we find our 2 spots, and then I draw my DR line from one to the next, going through the bases of these buoys, these objects. Measure the distance. Again, I want to put that little arrow so I know which direction I've gone on. And there we are. So in any of these types of problems where we're doing speed, time, and distance, what you want to do is set up your 60D street. It will help you determine what you know and what you're looking for. If I give you time, you're leaving at 11 and you're going to be there 11:15. Well, that's 15 minutes. Then you measure the distance. So you get a start and end point. The distance times 60, divide by that time, 15 minutes, and that will give you your speed. So we go back and forth in many regards that way. It's very simple no matter what you do, what the problem is. If you do it with the 60D straight, you really cannot go wrong. Okay, now we're going to do a 3-point fix. Again, these are pretty straightforward. And what I'm going to do is a very basic one. So we're going to go and we got object G here, and we got C, and we got D. So we're out here someplace, and we took these 3-point fixes, and then what we're going to do is find them. So we have here G is 083. So 083 is right there. So again, through the middle, come down to right there, making sure again that we're always through the little X. Okay, press down, lift up, and then we're going to run over to G, the base of the buoy again, and draw it back. Now, the interesting thing is we're from here to there looking at 083, but in fact we're drawing the inverse of that because we're here. Okay, the next one we got is C at 213 true. So again, I go to 213 true. There's okay, there's 20, there's 10. So 13 should be right about there. So everything lined up. I go to C. And again, remember the compass rule simply gives us an angle. We're not drawing through the compass rules. They can be located any place. The main thing we're just drawing is giving us our angles, what we want. And finally, D is 141. So here's 141. Again, making sure everything lines up properly. And we go to D, and we have our 3-point fixed. And that's what you want. If you want about that tight. Reality out in the water bouncing around, it's going to be a little bit bigger. Okay, so now we've done our speed, time, and distance, a 3-point fix, and finally, I want to do a distance off. So we are going to go from B down here, and we're going to head out at 328 true. So we're going to find 328, which is right there. And we're going to come out to B, and we're going to draw our DR line. Okay. The problem goes on to say that our speed is 14 knots, and we want to know when buoy J is a beam. Okay, here's buoy J, and to find out when it's going to be a beam, we set up our rulers such as this, making sure it's a 90-degree angle, and there. Now, our distance off, very simple. Again, we're going to grab center. And again, remember, this is a 90-degree angle. It must be 90 degrees. Okay, so our distance off, remember, we're not going to it, we're going by it. 1, 2, 3.2 nautical miles. So this is 3.2 nautical miles. Now our ETA to that point, again, we measure off 5. And we are going to go, there's 5. And then we're going to squeeze back. Oops. So we're going to squeeze back. And we have 5, 6, 7, 8, 9.5. So we're going to do our 60 straight again. So we got 60 times 9.5, and our speed was 10 knots. So what's our ETA? So let's do our math here. So we got 60 times 9.5, and we're going to divide by our speed was 14, which gives us 41 minutes. So our 41 minutes we would add to our start time. Let's say it was 11:30, so we will be there at 12:11. Okay. Now, so we've done a speed, time, and distance, which we can kind of repeat at a couple places, our 3-point, and our distance off. Well, the last thing I want to show you is a relative bearing. Okay, so we are going to go from G rather, excuse me, on a heading of 346. So we're going to come over here, and we're going to find 346. So there's 340, and 346 should be right there. I'm going to come over to G. And I want to extend it up a ways. Okay. So we're on our course of 346 true, and we're traveling at, find my problem here, at 10 knots, where speed is 10 knots. And then problems. Okay. We're going to travel for a period of time and we're going to take a relative bearing. And the relative bearing we're going to take off the front of the boat. Remember, again, the front of the boat is 0, 0, 0. So we've been traveling okay, now we got her. We're going from G at 346 true. We're traveling at 10 knots, and we left at 11:30. Well, at 12:07, our lookout up here reports a light, and I said, "Where?" Well, he says it's at 092 relative. So what do? Remember now, relative bearings. We take 92, and we're going to add it to 346, which is our ship's heading. And if we do the math on that, 346 plus 92 equals 438. Well, there is no 438. So we subtract 360, and lo and behold, so this bearing is 78 degrees true. Okay, so let's find 078 true and see if our problem worked out. Okay, there's 078. And we go up. Oh, forgot one thing. Very important. I'm trying to get ahead of myself. Where are we? Well, we're at 6.2 nautical miles, so we have to mark that. So first I'm going to do 5. There. Okay. Then I got to do 1.2. Which is right there. And see how we did. Okay. Come back down. Grab 078, which is right there, and run it up and see which light it is. And so basically we saw light M. So what do we have here? The steps would be, we got a start point. We're going at 346 true at 10 knots when at 12:07, which is 37 minutes later, we spot a light. It's not quite a beam. So we were reported at 92 relative to the front of the boat. When we do the math, it actually comes out at 078 true. So we do our DR. We next must do where we are when we spot the light. Don't forget that step, very important. And then to that, we add our heading and the relative, convert it to true, and away we go. So basically, that is how we do a relative bearing. It works out very well. Okay, I want to take just a couple of minutes and talk about how we work with our charts. And there's just a couple key features. I'm going to show you how to do a lat long in 2 different ways on this. Otherwise, the things we covered earlier are the same on a chart, no matter what you do, the same concepts are there. Okay, first, we always read from right to left, bottom to top. And the reason for that is the numbers and coordinates are going up. This chart happens to go all the way out. It starts at 72 degrees and will go up to 73. Again, remember now, a degree is 60 nautical miles. So these things don't cover, number of degrees. Usually it's 1.5 degrees at most. Okay, same thing going up. We're starting here at 40 degrees, and it looks like 55, 54, 53. So this starts at 40 degrees in 53 minutes. Here's at 55, then at 60, of course, it goes over to 41, and then continues to progress. So this is 41 degrees and 5 minutes. Again, these are 1 minute increments, no matter which way you go. Okay. So again, what I try to do anytime I'm taking measurements, I always try to line up on one of the lines to make sure everything's straightforward. If you don't, you're going to be crooked and you're going to get some very bad answers on it. So line them up on them over a little bit. There we go. Tip, roll, and then you can make a measurement. So let's go ahead and do a lat long for a particular item here. And let's take this buoy right here. So what we're going to do is establish a latitude and longitude for that buoy. So what we do again is we start at one of the full lines. This happens to be 10, 20. Now we're at 72 degrees. And if we start at 20 minutes, line it up here. Again, tip and roll. And remember, I said you were going to read from right to left. So I have 72 degrees, 15 minutes, okay? And I have another full minute right here. So that's 16 minutes and 1/10. So I would write that as 72, 16.1. So right there, so that's 1 minute, 1/10 of a minute, excuse me. So here we go again. So what I have is, at that point, the longitude is 72, 16.1. Let's do the latitude. Same thing. I'm going to line this up on one of the lines. Press, roll, tip. Okay. So we're going to go back over here. So what I have here is 4100, and this is 4101. So I'm at 41 degrees, 1 minute, and I would give it also a tenth. So it's 1.1. So that location for this buoy here is at 72 degrees, 16.1 longitude, 41 degrees in 1.1 minutes. Again, remember, these are the small hashes are minutes, or tenths of minutes, excuse me. And again, the full ones are a minute. So again, we got 55 here, 56, 57, 58, 59. Instead of going to 60, we go to the next full degree, which is 41. So this is 4100.0. We only go down to a tenth. Now I'm going to show you one other way of doing this, because when you're in the middle of a chart, your rulers are not going to make it. So what I can do as well is I go on one of the big lines. This happens to be one of the main latitude lines. And I put the dividers on that line and on the object. And I come over to the side here, and I got 41. In this case, I got 4101.0. So you can do it either way. And I can do the same thing here on the longitude. So I'm on the main longitude line here. Bring it down. And again, I'm going to read from right to left. So I got 72 degrees, 15, 16.1. Just what we had before. So you can either use the rulers or the dividers to do these lat longs, as long as you square up on the main lines. And that should get you pretty much through plotting. Again, it's just a matter of finding the buoys and following the protocol, the skills that you have. Best of luck.